Hi everyone, today we're going to talk about the third StatCrunch assignment that we have to do. This one deals with the t-distribution and the two-sample t-distribution where we actually have two independent samples. So we're going to take a look at an example first, and then I'm going to assign the assignment. We'll talk a little bit about that. Okay, so let me share my screen here. Naturally, my dog starts barking as soon as we're on this. That's enough, Callie. Sorry about that. And so basically what we have is we have two sets of data, okay? And we have two high schools. And we have the number of hours per week that students, randomly selected students from each high school work. Okay, so let's call this first high school, how about Heritage, and we'll abbreviate it as HS for Heritage High School. And let's have the next one be, how about, let's see, what do we want it to be? How about Bay City Western? So we'll say Bay City Western, okay? And so a researcher claims that the number of hours per week worked at each high school for high school students, we'll say high school seniors, was the same. So that means mu1 equals mu2. Okay, that would mean that if we look at it in the StatCrunch sense, they take the difference of the two. So if they're equal, mu1 minus mu2 would equal 0. If they're not equal, mu1 minus mu2 would not equal 0. Okay, so we're going to remember that as we move forward. So H0 would say that the mean number of hours that Heritage High School students work, which would be mu1, minus mu2 is equal to 0. That means they're the same, where mu2 is Bay City Western. And I'll make a note of that right here. So mean 1 is HHS, and mean 2 is, Bay City Western. Okay. And so, whoops, there's a typo there. We'll correct that. Mean 1 equals HHS. Sorry about that. And so now, this is going to be H0. Mean 1 minus mean 2 equals 0. Okay, so that's H0. Let's expand that a bit so we can see the whole thing. Okay, and now that HA would be not equal to 0. Let's say they're different. Now this is the claim, so I'll star it. There we go. Okay, let's suppose our level of significance is 0.05, so we'd report it. Okay, so can't do Greek letters very well on this, so basically I will say test level equals 0.05. Okay, now the t-score and the p-value I'm going to generate with the StatCrunch program. Okay, and so that's going to give me the parts 3 and 4, which then help me with part 5 and part 6. So let's take a look. Okay, so how do we do that? We go to stat and down to t-stat. And we have two samples, so we're going to choose two samples. Whoops. And we're going to choose with data because we don't have a summary. Okay, so now we're going to select HHS's variable 1, sample 2 is Bay City Western. Now, if we assume the variances are equal, the rule was we pooled. If we assume they're not equal, we do not pool. So if we don't check this, that means that we assume the variances are not equal and we would not pool. If we check this, the assumption would be that they're equal. So let's check it. Let's assume they're equal. Okay. Now here's our H0. Mu1 minus mu2 equals 0. That means they're the same. HA says mu1 minus mu2 does not equal 0. That means they're different. Okay. That's what we want. So we compute. And we have the following information. it says that our test statistic is minus 1.87. So that's our part 3. So t equals minus 1.87. Our part 4 is our p-value part. So the p-value equals 0.0818. And then for step 5, we look at this and we compare it with our level of significance. 0.0818 is greater than 0.05. So that means we're going to fail to reject H0. If we fail to reject H0, that means that if this is the claim, we can support it because we failed to reject it. If we didn't, if we failed to reject it. If we rejected it, then we could not support that claim. Okay, so now let's look at what we have to do because we're going to do something very similar to this. Okay, and you're going to have to show me, you're going to have to photocopy, or you're going to have to photo this screenshot, this output, okay, for steps 3 and 4 to prove that you did it. Okay, so now let's take a look at what we have to do. Okay, so let me share my next screen with you. And this is a document that you're going to get in the news item. So a random, below is a random selection of college students at school in 2 different majors, English and biology. They were asked how many credits they're currently carrying. The results are below. So we have English majors with a certain number of hours. We have bio majors with a certain number of hours. Okay. So you're going to put in one of the columns the English majors. You're going to label it as English majors. You're going to put in another column the biology major data. And then you're going to select T-stats. And you're going to select 2 samples, and you're going to select with data. Okay. From that, you're going to generate parts 3 and 4. Okay, because we're going to test this claim. A college dean claims that the number of credits carried by English majors is not equal to the number of credit hours carried by biology majors. At a 0.05 test level, is there enough evidence to support the dean's claim? Assume the population variances are equal. And you're going to have to fill in this information. You're going to have to fill in H0 and HA. You're going to have to insert the StatCrunch result here and here. Plus, you're going to have to take a screenshot of it and paste it to this document. Based on 3 and 4, can you reject or fail to reject the claim? Let's put H0. That's better than the claim. I like that better because that's really what we're doing. And then we're going to conclude if we can support or not support. And again, see the video for the example, because really I talk about everything you need to do for this assignment. Okay, expect the 4th assignment in the next day or 2. Okay, it's going to be a chi-square distribution problem and an ANOVA problem. So we're going to have 2. And then we're going to move into non-parametric stat for a while. Okay, so we're getting to the end. We're getting real close. Okay, so keep that in mind as we move forward. Hopefully this helps you out. And this, again, like all the other computer assignments, is due on the 10th of December. Take care. We'll see you next time.